Hello, this is Mr. White, and this video is on the law of signs, the ambiguous case. And that title reminds me of an old Saturday Night Live sketch from the late 1990s, early 2000s. And I'm curious how many of you youngins recognize this picture from the sketch, but I should probably not say too much more about that. Let's get into the lesson. If you don't already know the word ambiguous, it means open to several possible interpretations. It's unclear. And that's what we're going to be dealing with something today, something that's unclear and has several possibilities. But let's start with something that is not ambiguous. Let's refresh our memory from geometry class about those four congruence conditions, or those four uniquely defining triangle conditions: SAS, SAA, ASA, and SSS. So I'll show you a quick example of the SAS case that you see here. And just to remind you how that works, we see that big A, the angle, is 34 degrees. And little b is 5 units long. And it doesn't really matter whether I consider little b to be down here or whether I consider little b to be this side over here. It doesn't really matter as long as it's not across from big A. Because remember, little a has to be across from big A. Little b has to be across from big B, etc. So as long as I don't violate that condition, then I'm good. So I'm going to leave little b up here, and I'm going to recognize that therefore little c has to be down here. I don't have any other choice. Again, it cannot come over here because then it's across from big A, and that can't be. Little a has to be across from big A. So let's bring little c back here. And once I have satisfied those conditions, there's really no other way for me to complete this triangle other than to connect these two sides, or these two vertices. And again, since little a has to be here, big B has to be across from little b, big C has to be across from little c, and someday, in fact in our next lesson, we'll determine how do we figure out what these values are. But we're going to save that for another day. Today we're just going to explore what's going to be called the ambiguous case. And the ambiguous case comes up when you deal with SSA. Now let me be clear, SSA is not always ambiguous. Your geometry teacher probably told you to stay away from it, not just because it made you snicker when you read it backwards, but because again, it was ambiguous, but sometimes it works, sometimes it doesn't. It's not clear. And rather than try to deal with these little toys here, I'm going to turn to my favorite toy, GeoGebra, and let's explore an SSA case in GeoGebra. All right, so here's an SSA case. And it's an SSA case because here I have a side, S. Right next to it, I have another side, S. And then right next to that, I have an angle A. So SSA is what we've got here. And we see in this SSA case, there really isn't even a triangle being formed. That little a is too small to reach the ground, so I don't really have a triangle at all. Now, what if little a were bigger? So what if little a got somewhere around here? Or bigger, I'm almost at the point where it's reaching the ground. I've almost got a triangle. And in fact, if I just get it, if I'm wondering how long does it need to be in order to form a triangle, well, we could use our right triangle trig to figure out exactly how long it needs to be to reach the ground. Let me show that. If you look at the right triangle being formed there with the pink leg, you could use your right triangle trig to determine that b times the sine of angle A. That gives you that minimum length needed for to reach the ground. Okay, and again, in our next lesson we'll do that. But for right now, let's just look conceptually. In fact, I'd invite you on your calculator, bust out your calculator and calculate what b, again 25 here, times sine of 34 degrees, or A. Calculate what that is on your calculator. I'm not going to do it here, but you do that. And it's probably something close to what little a is right now. All right? So I'm just going to do it here in GeoGebra. And looks like I'm getting close, and I'm going to say it's going to get to 14. Oh, just short of 14. I have a triangle all of a sudden. Okay, so now I have a single triangle, and if I make A even bigger, I enter the ambiguous territory. So if I make A bigger, now I have two possibilities. I could either use this leg and form this triangle, the darker one here, or I could be using this leg here, and I could be looking at this triangle. It's ambiguous. It's not clear from the given information which one I should be looking at. That's why your geometry teacher told you to stay away from it. All right, but let's not stop there. What if I kept making A even bigger? It's getting bigger, getting bigger. Believe it or not, we're eventually going to enter unambiguous territory again, and here's why. If I make A big enough so that it's bigger than little b, bigger than that 25 length, we will see that it is no longer ambiguous. Now, you may be wondering, why did I gray out this leg over here? Well, the reason is because if we were to consider this leg over here, I'm no longer dealing with a 34-degree angle. Notice that big A would no longer be 34 degrees. It would be this obtuse supplement. It would be 180 degrees minus 34 degrees, or 146 degrees. That's what the value of big A would be. That's why I don't consider this triangle over here, because A was given to be 34 degrees. However, this side over here is still valid, so I would unambiguously have one triangle. All right? I'm going to make this GeoGebra file available to you on the class website so you can play around with it as you wish. But let's try to summarize this on paper. Again, I hope you really need to understand the logic behind this, but let me show you what I would suggest you put in your notes. Leave yourself about half a page of notes for this. Here's a textbook definition of the ambiguous case if you find this helpful. You can pause and read this. And likewise, in the current version of our textbook, on page 480, you see this exploration, and I'm basically doing a variation of this. So if you'd like to look at this in the textbook, if you find that helpful, I welcome you to do that. But this is what I'm going to suggest you put in your notes. And again, don't make this really tiny. Leave yourself about half a page for this. You want a table here with 4 cases. And I would title it something like the SSA ambiguous case. And we're going to look at big A being given as well as little a and little b. But consider that there may be other variations. We could be given big C and then little c and little a, or something like that. So don't get too married to that one, the one case of big A, little b. Okay? So again, on about half a page of paper, make this table, and let's fill in the first case. And I want you to recall what we saw in GeoGebra. We first saw little a was too small to even reach the ground. Little a was even too small to reach the ground. And if we remember comparing it to the minimum length it would need to be, that minimum length was b sine a. Again, that's just our old right triangle trig at work here. So if little a is less than whatever the calculation of b sine a is, and remember, this is given information. You can put it into your calculator. And if little a is less than b sine a, you've got this condition in which there are 0 possible triangles. All right, the next case we saw in the GeoGebra file, which again, I welcome you, even if you want to pause right now and go to the class website and play with the GeoGebra file before you continue, that may not be a bad idea. But the next case was where little a was just long enough to reach the ground. And in that case, we had a right triangle, a single right triangle. And that was when little a was equal to b sine of a exactly. That's where we had one triangle. And you might want to note that it's a right triangle in that case. Okay? The third condition was the ambiguous one. The third condition was where we compared little a to b sine of a, and we found that little a could either swing in this direction or it could swing in that direction. So again, it was ambiguous as to whether we should be looking at that triangle or that triangle. That was the ambiguity. So I'm going to call this A1, and I'm going to call this A2. We'll use that more in the next lesson, really, but I want to just set you up for that. So we'll say if B sine of A is less than A, or if you prefer to think of that as A being greater than B sine big A, you may conceptualize it as that as well. That's two possible triangles. And again, note that that is what we call the ambiguous case. All right. Finally, we said if A keeps on, or if A is big enough such that, and notice I had to switch my picture up a little bit here. If A was bigger, little a was bigger than little b, then it would either swing to this side, way over here, or it would swing to this side, way over here. But remember, we can't really count this triangle because then big A is no longer this value here. Big A is going to be this obtuse angle here. And that would not be valid because you're given big A and it presumably is not obtuse. Okay? So we won't count this one over here. We will only count this little a over here. And that was where B was less than A, or if you prefer, little a is greater than little b. That's where we're back to one possible triangle. It's unambiguous. All right, and again, I repeat, don't get tied to this idea of only dealing with big A and little b. It's going to switch up, so you really need to understand the logic behind this. Your purpose of the note, that this table in your notes, is just to document your thoughts and use it as training wheels to refer to when you're just starting out. Okay, so let's do an example in which I don't use these variables. Here's our example. This is exactly the wording you're going to see in the book and on the tests. State whether the given measurements determine 0, 1, or 2 triangles. And in this case, we're dealing with big B, little b, and little c. So here's how I would think through it. I would just tend to get in the habit of always saying, I'm going to draw my angle in this orientation. It obviously doesn't have to be that way, but that's how I choose to do it. And try to draw it reasonable, I would suggest. So I'd say this is a reasonable 49-degree angle. It's a little bigger than what we know 45 degrees to be. So call that 49 degrees, big B. And remember, little b has to be across from big B. So I'm going to now turn my attention to little c. And remember, little c, on the other hand, little c could be down here, or it could be over here. You have a choice, but I'm going to recommend you just make it a habit to make little c be in this orientation. Make that little c. And then conceptualize that swinging pendulum of the GeoGebra graph. And ask yourself what that length is. And hopefully you're going to say, okay, that's going to be, oh, and let me note that c is equal to 10 units on the picture. And that distance there, using our right triangle trig, is going to be 10 sine of 49 degrees. So we turn to our calculator and figure out what the value of 10 times sine of 49 degrees is. And we see it's about 7.547. And so I'm going to put approximately equal to 10.5, 10, what am I doing? 7.547. And I would encourage you to note that on your paper. And then you very clearly see that if little b, which is across from big B, is a length of 8, it's bigger than this, but less than this. So little b is between those two values that are underlined in green. Therefore, it could either swing to this side or it could swing to this side, and we have the ambiguous case. And again, we'll wait till next time to actually solve those two possible triangles. But to answer the question that was put here, we would just say that is 2 triangles and call it a day. All right, I hope that made sense. As always, if it didn't, come by office hours. Here are several for you to try. You know the drill. Pause the video, please, and give it a shot. All right, I'm going to assume you've done your duty here, and let me reveal the first 2 solutions. those are the first two solutions, and I've highlighted the quantities that you need to be comparing. And in the first case, there's 0 triangles. Second one, there's 1 triangle. If you didn't get that, I'd ask that you go back and check and see if you can figure it out and try C and D again. But if those two are good, let's go on to C and D. Okay, and there are C and D. 2 triangles and 1 triangle respectively. Hope that made sense. Come on by if not.